Welcome to a video on investing with regular installments. So a good example of investing in regular installments is superannuation. But the contribution that's normally made is a percentage of your wage. So over your lifetime, your wage increases. But for the purposes of what we're going to be looking at, we're going to assume that the amount regularly invested stays the same. As well as the compounded rate, unless you're told otherwise, in which case you'll stop the superannuation at that point in time and you'll start a new one from there on. So the steps to follow is because you make multiple installments, so whether it's monthly or yearly, fortnightly if you're on a fortnightly pay, you're going to use the compound interest formula for every installment for the length of the time that it's going to stay in there. And you'll leave it in index form. So don't calculate it on use your calculator and get the exact amount. Just leave it in index form, because when you write that out as a pattern, it becomes a sum of a GP. And that's how we calculate the total investments over the lifetime that it's in there. So here's an example. So Fiona's grandparents decided to invest $2,000 when Fiona was born, and they continue to invest $2,000 every birthday until they turn 20. So that means that on their 21st birthday, they gave Fiona the sum of money, and the amount that it was invested at was 5% per annum, compounded annually. So remember, in the last video we did on compound interest, the compounded amount, compounded annually in this case, is what all of your what your rate needs to be in, which it is 5% per annum, and what your investment needs to be in, which is $2,000 every year. So the first one, using our formula, A equals P 1 plus R to the N, the first amount that was invested when Fiona was born is invested for 21 years. So 2,000, 1 plus 5% to the 21. So we could write that as 2,001.05 to the 21. But let's just create the series. Second amount's only in for 20 years. Third amount for 19 years. And the final amount, the 21st amount, only stays for 1 year. So that was invested on Fiona's 20th birthday, and it'll be in there for that 1 year, and then Fiona will take it out. So rearranging it to, instead of 1 plus 5%, make it 1.05, writing it out as a sum. So that first one was the first amount she invested, that was invested for Fiona, 2001.05 to the 21, all the way down to that last. Recommendation is rewrite it in ascending order. Makes the R value a lot easier. So just flip it around, start at 1.05 to the 1, 1.05 squared plus all the way up to 1.05 to the 21. What you'll notice is that we have a sum of a GP. So the first term is 2001.05 to the 1, R is 1.05, and N is 21. So when we put that into a formula, Fiona's going to end up taking out just over $75,000 on their 21st birthday. Question 2. So we're going to do it very slightly. We're going to work out what age Fenway can retire if they decide to invest $100 every fortnight. So at the age of 18, start working, going to do $100 every fortnight. The interest rate is 0.23% per fortnight. So when we get our N, it will be in fortnights until they achieve $1 million, and then they want to retire. So like we did last time, first amount is invested for N years this time, because we're not sure how long, and it's 1 plus 0.23%. Second amount is N minus 1 years, because it's 1 less than the full length of the life. third amount's n minus 2 years, and the nth amount, whatever that happens to be, is only invested for 1 year, because at the end of that year, Fenway will have over $1 million. Now, 0.23% is 0.0023. So when you add 1 to it, you get 1.0023. Remember, write it in ascending order. So it's 100, 1.023 to the 1, all the way up to 100 lots of 1.023 to the n. That once again is a GP. GP where A is 100 lots of 1.023 to the 1. The R is 1.023 and N is what we're trying to find. So let's sub it into our SN of a GP formula. And we know that we want it to be greater than 1 million, or if we say equal 1 million, then we can work it out and we'll round N up because that's how long Fenway needs to take, how many fortnights. So working it out as a calculation, you end up with 1.023 to the n equals the fraction that we had plus the 1 that we bring over. So 1.023 to the n is equal to 23.94. Use our exponential converting to a logarithm, and you get 1,383 fortnights. Divide that by 26. So that turns out to be 53 years, which then when you add that on to the 18 years is approximately 71 years of age. Fenway can retire and have $1 million. Thank you very much.